Okay, so our next question, this is part 3 of the lesson 2 videos. Again, I'm breaking it into parts just so I can get them up quickly. And anyway, here we go. So compute the empirical formula of the following compound. So you have an HO compound, you need to figure out the subscripts. And in the lab, you did a decomposition reaction. So that would be this breaks down into hydrogen and oxygen. So you have 0.857 grams of hydrogen and 6.86 grams of oxygen. So the first step is compute the moles of H and O using the molar masses. Okay, so let's go ahead and do that. So over here I'll do hydrogen because I have space up there, so I'll work up there. So 0.857 grams of hydrogen. And off of your periodic table, look at hydrogen and you have 1 mole is 1.01 grams of hydrogen. So 1.01 grams per mole is the molar mass of hydrogen. Okay, for oxygen, we'll do the same thing over here. And we have 6.86 grams. And look at your periodic table, 1 mole of oxygen is 16 grams. Okay, and we do our calculation on those. And for hydrogen, that gives us 0.85 moles of hydrogen. And for oxygen, that gives us 0.43. Okay, so those are the numbers we're going to use in our calculation down below. We don't need to deal with grams anymore here. Okay, so we computed those, the molar masses, so let's just go ahead and write that down here. Okay, the second step says create a ratio of the number of moles of each element you obtain. Place the smallest number of moles on the bottom of those ratios. So for hydrogen, this will be our ratio. The smallest number was the 0.43 for oxygen. And for oxygen, this is the ratio. You're always going to have one of the ratios that is 1. And this approximately equals 2. And this approximately equals 1. Okay, so it says multiply the top and bottom fraction by a whole number until you have whole numbers on the top and bottom. So for hydrogen, we have a 2, so that's a whole number already. It's not exactly 2, but it's within 0.05. If you actually did that calculation there, you get 1.976. That's close enough to 2 to call it 2. So somewhere between 1.95 and 2.05 would be close enough to just call that 2. Okay, so that means that we have a whole number there and a whole number there, so we don't even need to do step 3. So that step is done. So place these numbers as subscripts. So for H, the number is 2, and for O, the number is 1, and you don't ever have to write that. So there you go. So that's your empirical formula. Now it says the mass of 1 mole of the gas, molar mass, was found to be 18 grams. What would the molecular formula, that is the actual compound, be? So the way you do that is you create a factor that you're going to multiply these subscripts by. And that factor equals the actual molar mass over the empirical formula mass. Okay, so what's the molar mass? Well, they gave it to us. It's 18, so that's 18 on the top. And what's the empirical formula mass? Well, it's H2O, so you probably know this, but H, you have 2 times 1.01 equals 2.02. And for oxygen, you have 1 times 16, which equals 16. And when you add those, I'll write it over here so you can see it, it's 18.02. So we put that on the bottom. And when you divide 18 by 18.02, that's close enough to 1. So we're just going to call that 1. And so that's the factor. That means you really don't have to multiply by anything. H2O is the empirical formula, and it's also the molecular form. It's the actual formula of the molecule. Okay. All right, so this is the molecular formula as well, H2O. Okay, we'll do one where they're not the same, and you'll see what the difference is in case that still isn't clear to you. Okay, let's try another. This one has 3 elements in it. So compute the moles of C, H, and O using the molar masses. So I'll do that down here. I'm going to have to start way over on the left because it's going to stretch all the way across the page here. So for carbon, we have 60 grams. Times molar mass off of your periodic table. There's 1 mole. Okay, and we'll compute that in just a minute. For hydrogen, we have 4.48 grams. And finally for oxygen, okay, and now we'll do the calculation. And those calculations produce 4.99 moles of carbon, 4.44 moles of hydrogen, and 2.22 moles of oxygen. So what we're going to do now down here is create 3 ratios by putting the smallest one, which is 2.22, on the bottom of each. So we'll go ahead and do that. So for carbon, and you always have one of them that's going to end up being 1. That's the one with the smallest number of moles. So this one's going to be 1. This one you could just look at it and see that's going to be 2. And this one, let's go ahead and do it if you can't look at it and see it. So it's going to be it's going to be 2.25. Okay, so these are the 3 numbers we're dealing with. So that means our initial subscripts are going to be C, 2.25, H, 2, and O, 1. And I'll go ahead and write the subscript because we're just in the calculation stage. So you want to see what that number is there. Okay, so 2 of the 3 are whole numbers. This one is not a whole number. So what you want to ask yourself is, what do you have to multiply by to get a whole number? Well, I can just tell looking at it. 2.25, you can do this on a calculator if you need to. 2.25 times 2 is going to be 4.5. 2.25 times 3 is going to be 6.75. And 2.25 times 4 is going to be exactly 9. It is a whole number. So that means that we multiply all of these by 4. Okay, so we're going to do 2.25 times 4 equals 9. For carbon, 2 times 4, you have to do it to all of them even though these are already whole numbers, equals 8, and that's for hydrogen. And 1 times 4 equals 4, and that's for oxygen. So those are going to be your subscripts because those are whole numbers. So therefore we're going to have C, 9, H, 8, O, 4. And that's the empirical formula right there. Okay, so now we ended up with C9H8O4. I've had to switch sheets due to a little accident. So what now we want to know is what's if the molar mass of the compound, and there was a mistaken number here, it should be 360.57, what is the molecular formula? In other words, this is an empirical formula. It's not necessarily the formula of the actual molecule. So what we need to do is, first of all, we're given this, and we have a factor that we did on the last problem. And that's the molar mass over the empirical formula mass. Okay, so for the empirical formula mass, take this and we figure out what the mass of that is. So you have carbon. There's 9 carbons times 12.01. For hydrogen, you have 8 hydrogen times 1.01. And for oxygen, you have 4 oxygen times 16. Okay, so this one comes out to be 108.09. This one is 8.08, and this one is 64. So you add those together. And you get 180.17 grams per mole, or grams, yeah, for one mole of that. Okay, so now we take the molar mass that was given to us right there. So that's 360.57 over this number. That's the empirical formula mass. So you have to be given the actual molar mass of the compound, and how would you find that out? Well, what you would do is, we learned when we studied gas laws that any gas at standard temperature pressure, which is 0 degrees centigrade and 1 atmosphere, just the normal air pressure in our classroom, is going to have a volume of 22.4 liters. So let's say you had a container that was exactly 22.4 liters. You evacuated it, you pulled all the air out of it, and then you put a hose up to it and started pumping this gas in, C9H8O4. And the pressure starts to go up, and when it gets to 1 atmosphere, you stop, and then you control the temperature. You're keeping it controlled at 0 degrees centigrade the entire time, and you seal it off. So now you have a gas, this gas, at 1 atmosphere, 0 degrees centigrade, occupying a volume of 22.4 liters. That means you have exactly 1 mole of this gas. So that means that if you then weighed the container with that gas, you would then freeze the gas. You can just freeze it so that it all condenses down on the bottom. You stick it on a scale, you weigh it, you subtract the weight of the container, and that'll give you the weight of the gas, and that's what you came up with. So it's just a little thought experiment. How could you figure out this weight if you didn't know what the gas was? So that is the weight, the mass of 1 mole of the gas. That's the gas's molar mass. Okay, the empirical formula mass was this. So now when we divide these two, we get a number very close to 2. So that becomes our factor. The factor is 2. So now what we do is we take each of these subscripts and we multiply it by 2. So that means the actual molecular formula, that's the formula of the actual molecule. That's going to be 2 times all of these numbers. So it's C18, H16, O8. And that's the final answer there. Okay, I'm going to leave off with these problem sets for today. We're going to come back and work on this more later. I don't want to do all of these today. I want you to study these. We'll come back to this in a few days, do some more of these. And I will post all the solutions for all of these sometime in the future, in the near future. Okay, so have a good day.